This lesson is for Mrs. Cucci's College Now PreCalculus class. We are on lesson 5.1, trig functions of acute angles. Okay, so if you want to open up lesson 5.1 and go to page 1.15, that's where we left off, and we can get started. Okay, so we're going to deal with some word problems here. So the first one, we're going to talk about the distance to a fire cave. Massive trees can survive wildfires that leave large caves in them. Hiker observed scientists measuring a fire cave in the redwood tree in Prairie Creek Redwood State Park. He estimated that he is 80 feet from the tree and that the angle between the ground and the line of sight up to the scientists is approximately 60 degrees. Approximate how high the fire cave is and round your answers to the nearest foot. All right, so what we need to do is we need to be able to read this and from this description draw a picture that makes sense. Okay, so we have a hiker that's standing 80 feet from a tree. Okay, oops. So I've got my tree here. All right, put a little top on it. There's my tree. Okay, my hiker is right here. He's standing 80 feet from the base of this tree. Hello. Okay, there's my hiker. He observes that scientists are up in a fire cave, so a hole that's been put into the tree from a fire. And he believes that from his place on the ground, he's looking up at an angle of about 60 degrees. Okay, this is his line of sight. So this is an angle of elevation. So we want to determine, based off of this information, the height at which the scientists are, where that fire cave is. So if we're looking at the angle that we're using and the two sides that are important to us, we have to try and figure out what trig function is being used. So I've got my angle, I've got the side opposite, and I've got the side adjacent. So we need to know what trig function contains the side opposite and the side adjacent. So the first one that comes to my mind, of course, is tangent. Okay, tangent we know is opposite over adjacent. So tangent of my angle, which is 60, equals opposite, which for us is h, over adjacent, which is 80. So what we need to do is we need to be able to solve this trig equation. So all this is it's just a regular equation. If I wanted to take and solve for h and this was one number, say it was 60, just 60, how would I solve it? So the goal is to get this h alone. Well, what we can do is we can multiply both sides by 80 so that we get 80 tangent of 60, 80 times tangent of 60 equals h. So how do we find this value? Well, we know a few things. We know that tangent is 60 based off of our chart and our unit circle. Again, tangent is sine over cosine. Tangent of 60 is sine of 60 divided by cosine of 60. Sine at 60 degrees is the square root of 3 over 2. Cosine at 60 degrees is 1/2. Complex fractions, we know we multiply by the reciprocal. So 3/2 times 2 over 1. We get square root of 3. So this is essentially 80 times the square root of 3. Since we're looking for height, we know that we generally don't speak about height in terms of radicals, so we do want to find an approximation here. So that's going to bring me back to my calculator. And I'm going to do 80 times the square root of 3, right in my calculator. Oops. And I get approximately 139 feet. Okay, and that is an approximation again. And you do want to make sure that you include your units. So the fire cave is approximately 139 feet high. Okay. Okay, so we also need to talk about degrees, minutes, seconds, and we did talk about this a little bit last year, not too much in depth. One minute, this is your notation for 1 minute. That little apostrophe is a minute, okay? 60 minutes is going to be 1 degree. So 1 minute equals 1 divided by 60 times 1 degree. 2 little apostrophes, that's going to be your 1 second. 60 seconds is equal to 1 minute, as you guys already know. So we're just going to use kind of the information we already know to go where we need to go. So we want to convert 5 degrees, 42 minutes, and 30 seconds degree decimal notation, decimal degree notation. Okay. Now we can very easily convert this to degrees using our calculator. So I'll show you how to do that, but you do also have to know how to do this by hand. So what we're going to do is we're going to put this right into our calculator, and we do have a template in here for degrees, minutes, seconds. Okay, so we've got 5 degrees, 42 minutes, and 30 seconds. And all we need to do is we need to hit our book. Actually, let's make sure that we are on the other end here, so you're past the seconds. We're going to go to our book, and we are going to select tab 1. And we want to go down to DD, which stands for decimal degrees. I could hit D, and that would bring me there faster. Oops. Okay, so right here. So DD, we're going to select it, and then I'm going to hit enter, and it's going to give it to me in degrees, so about 5.71 degrees. So in the calculator, it's very quick and simple, but again, you do have to know how to do it by hand. Okay, so what I know is that this is equal to 5 degrees plus 42 minutes plus 30 seconds. Okay. What we're going to do is we're going to take that 30 and we're going to divide it by 60 so that we're able to adjust it to minutes. Okay, that's written as minutes, which we know 30 over 60 is 1/2. So this is a half a minute. 30 seconds is a half a minute. So we can adjust this to 42.5 minutes. And then we want to write this as degrees. So in order to write that as degrees, I'm going to take it and divide it by 60. Okay. So what this gives me is 5 degrees plus this is about 0.71. So what I have is 5.71 degrees. Okay, so you start with the seconds divided by 60, then add that onto your minutes, divide that by 60, and add that onto your degrees. Okay, so 72.18 to degrees, minutes, seconds. Okay, so we're going the opposite direction. And of course, this can be done in the calculator as well. So I'm going to put in my 72.18, and I can put my degree symbol in there if I'd like. And I want to convert this to degrees, minutes, seconds, which the notation for is DMS. So again, you're going to go to your catalog, and you're going to scroll down until you see that DMS. Whoops. Degrees, minutes, seconds. There it is. Okay. We're going to select that, hit enter, and we get 72 degrees, 10 minutes, and 48 seconds. Of course, this can be done in our calculator or by hand, which we're going to take a look at that as well. Okay, so what we're going to do for this one is we're going to break it apart. We know that this is the same as 72 degrees plus 0.18 times 1 degree. This is the same thing, right? We've split apart this piece here to 0.18 times 1. So this is still 72 degrees plus 0.18, but I know that 1 degree is equal to 60 minutes. So we're starting to convert. Okay. So when I multiply these two together, I wind up with 10.8 minutes. Then what I can do is I can go ahead and break this apart. 10 minutes plus 0.8 times 1. So I'm just pulling it apart. 72 degrees plus 10 minutes plus 0.08 times 60 seconds. 1 minute is 60 seconds. Okay. We're going to multiply this piece here now. When I multiply that, I get 48 seconds. So in degrees, minutes, seconds, I have 72 degrees, 10 minutes, and 48 seconds. Okay, so we're going to find each trig function value rounded to 4 decimal places each, and we're going to use our calculator to find these values. So the first one we're going to deal with is tangent of 29.7. I'm going to go ahead and add a calculator page. And I want to make sure that I am in degrees, which I'm not. So what I'm going to do is I'm going to come right up here, and I'm going to go to my handheld setup. Oops, I'm sorry. To my document settings. Okay, so you want to make sure that in your document settings, your angle is in degrees. Okay. We're going to make that default. So again, the first one we're going to look at is tangent of 29.7. You're going to go to your trig key, choose tangent, and 29.7. I'm going to type that right in, and since I already am in degrees, it should be just fine. You can check by hovering up here. Notice it says DEG. We're going to hit enter, and we get 0.57039. Okay. So rounded to 4 decimal places, we're looking at 0.5704. The next one was secant of 48. So again, you're going to use your trig key, select secant and 48. And we get to the nearest 4 decimal places, 1.4945. And the last one is using our degrees, minutes, seconds. And it's going to be sine of 84 degrees, 10 minutes, and 39 seconds. So we're going to use our template for degrees, minutes, seconds, and we're going to put that right in. 84, 10, and 39. And we get to the nearest 4 decimal places, 0.9948. Okay. Find an acute angle to the nearest tenth of a degree whose sine value is approximately 0.20113. Okay, so we know that sine is equal to sine of an acute angle, we'll call that angle x, is equal to 0.20113. Okay, so what we're going to do is we're going to go ahead and learn how to use sine inverse. What happens when we take the inverse of this is these two things actually flip-flop places for us. It's like switching your x and y, okay? And that's going to equal x. And we can very easily find that value by inserting a calculator page. So sine inverse 0.20113. So we get about 11.6 degrees. Okay, that is the angle. It's what you're finding is the angle. So x is approximately 11.6 degrees. Okay, this is always representing the angle. Ladder safety. A window washing crew has purchased new 30-foot extension ladders. The manufacturer states that not HTE, sorry about that the safest placement on the wall is to extend the ladder to 25 feet and to position the base 6.5 feet from the wall. What angle does the ladder make with the ground in this position? So this is another one of those ones where you have to think about what the problem is actually asking and what it looks like. Okay, you've got a building. We know buildings, generally speaking, create a 90-degree angle with the ground. All right? They want us to extend the ladder 25 feet. So the height, or the length of the ladder, I should say, is 25 feet. And place it from the base of the wall 6.5 feet. We want to know this angle here. Okay? So again, we have to think about what we have, what sides we have. We seem to have the adjacent and the hypotenuse. So which trig function includes adjacent and a hypotenuse? Well, that's going to be our cosine function. So we can say cosine of the angle x equals our adjacent side over our hypotenuse. So how do we find the angle? We take the inverse. And when we go to put this in our calculator, we get x to be approximately 74.92993.786 degrees. To the nearest degree, we could say that that's 75-degree angle. Okay, so this would be best put at a 75-degree angle. Okay, the last thing we're going to talk about is cofunctions and complements. Cofunction identities run as such. I've got sine theta equals cosine of 90 minus theta. Tangent equals cosine of 90 minus theta. Secant equals cosecant of 90 minus theta. So essentially what we're looking at is we're looking at a shift, a horizontal shift by a factor of 90. So given that sine of 18 equals, or is approximately 0.3090, and cosine of 18 is approximately 0.9511, and tangent of 18 is approximately 0.3249, find the 6 trig function values of 72 degrees. Okay, so using our reciprocal functions, we can say that cosecant of 18 degrees is equal to 1 over sine of 18 degrees. So this is approximately 3.2361. Essentially what I did is I took that sine of 18 and I replaced it with what sine of 18 equaled. And that popped it in my calculator. Similarly, we can say that secant of 18 is equal to 1 over cosine of 18, which is approximately 1.0515. And of course, cotangent of 18 is equal to 1 over tangent of 18, which is approximately 3.0777. So since 72 degrees and 18 degrees are complementary, remember complementary means that they add up to be 90 degrees, we can say that sine of 72 is equal to cosine of 18, which is equal to approximately 0.9511. Okay? Or tangent of 72 is equal to cotangent of 18, which is approximately 3.0777. Secant of 72, oops, is going to be equal to cosecant of 18. And these all come from the last page, our identities over there. Okay? Cosine of 72 is equal to sine of 18, which is approximately 0.3090. Cotangent of 72, and I know I'm over on time, just give me 1 second. Tangent of 18, 0.3249. And cosecant of 72 is equal to secant of 18, which is approximately 1.0515. And again, these, where I'm getting these from, is if we go back and take a look, we've got what they're equal to. Okay? All right, guys, that's all for today. Comment with any questions that you have, and I'll see you in the morning.